Today we were looking at Unit 1, Lesson 7, Creating Scale Drawings. So we're going to determine the scale of a scale drawing when we know the lengths of the drawing and the actual side lengths, know how different scales affect the lengths of the scale drawing, and when I know the actual measurements, create a scale drawing for a given scale. So here we have a rough sketch of Noah's bedroom, but it's not a scale drawing. A bedroom wouldn't have wavy walls. It says the actual length of wall C is 4 meters. To represent wall C, Noah draws a segment 16 centimeters long. What scale is he using? Explain or show your reasoning. Well, we talked about last time that a scale is a ratio with units, and it tells us how to go from the drawing to the real life. So something as simple as 16 centimeters to 4 meters. And then we could scale that down, equivalent ratios, and we could say it's 4 centimeters to 1 meter. We could say it's 1 centimeter to 1/4 meter. The actual lengths of wall A and wall D are 2.5 meters and 3 3/4 meters. Determine how long these will be on Noah's scale floor plan. Well, we could use our ratio table, centimeters to meters. So we have 16 to 4, 4 to 1, 1 to 1/4. For letter A, or for wall A, 2.5 is my meters. Well, to go from 1 to 2.5, we're multiplying by 2.5. So 4 times 2.5 gives us 10 centimeters. And then for wall D, 3 3/4 meters. So we're going to put that down here in the meters. To go from 1 meter to 3 3/4 meters, we multiply by 3.75. So 4 times 3.75 gives us 15 centimeters. And then we looked at the state of Utah, and we noticed it kind of looks like a rectangle with a chunk cut off. It actually also reminds us a little bit of Noah's bedroom. If I think about this right here, just flip the other way. And so we're told a rectangle around Utah is 270 miles wide and about 350 miles tall. The upper right corner that is missing is about 110 miles wide and 70 miles tall. And so we're to make two different scale drawings, one where 1 centimeter represents 50 miles and one where 1 centimeter represents 75 miles. So I'm going to start by labeling the dimensions that we know, and we're told that it's 270 miles wide, 350 miles tall. The chunk that's taken out is 110 miles wide and 70 miles tall. And then there's two sides that we have to figure out. So this piece right here, the whole width is 270 miles, and this piece is 110 miles. That makes this 110. So 270 minus 110 gives us 160 miles. And if the whole height is 350, this would be 70. So 350 minus 70 gives us 280 miles for this section right here. So scale drawing A is 1 centimeter to 50 miles. And my scale is saying, well, to go from centimeters to miles, we multiply by 50. But I know the miles, so I need to go backwards to find the centimeters. So we're going to divide each of those miles by 50. 350 divided by 50 tells me I need 7 centimeters for the height. 270 divided by 50 tells me I need 5.4 centimeters for the whole bottom. And I've already done all the calculations for us, and you can see our dimensions there. And I've drawn with a ruler and measured it out. And there's my scale drawing. Then we wanted to create diagram B, where we had 1 centimeter to 75 miles. Which one do you think is going to be bigger, A or B? Well, again, to go from centimeters to miles, we're going to multiply by 75. So to go backwards, we have to divide by 75. Now in this case, we're going to have to round because I can't be more accurate than to the nearest tenth of a centimeter. So I'm going to say 4.7 centimeters. 270 divided by 75 is actually 3.6 centimeters. And so when I go back over here, there are all the calculations, and I rounded to the nearest tenth, and you can see it is a much smaller drawing, which makes sense. If 1 centimeter is representing more miles, I'm going to need less of those centimeters. Now the question also asked us what scale factor would create drawing B from drawing A. Well, I want the scale factor from A to B. I'm creating B from A. 3.6. If B is smaller, I know it has to be smaller than 1, divided by 5.4. And yes, you could do it with a calculator, but we can also change those to 36 divided by 54, which simplifies down to 2/3. So the scale factor to create drawing B is 2/3. If we think about the miles in the drawing, to go from 50 miles to 75 miles, 75 divided by 50 is 3/2. How are 3/2 and 2/3 related? Well, they are reciprocals. So if I have two scale drawings and I know the scales, I can figure out the scale factor by finding the scale factor for the real life distances and then do the reciprocal. So for example, if I had drawing C that had 1 centimeter to 100 miles, well, 100 divided by 50 is 2. So this one is, I'm using twice as many miles per centimeter, which means then the scale factor from drawing A to drawing C is 1/2. So remember, the larger the real life measurement, the smaller the drawing.